Hey, Honors Geometry. Today we're going to get into the second part of our 9-2. This is translation in the coordinate plane. So translating is when we're going to move something in a particular direction. We call it a vector. So we have this little vector notation that kind of looks like a point, but it's not. These are little like kind of angular brackets. And so what that says is we're going to move in this direction. A is the amount that we're going to go in the x direction. So we're going to add A to the x coordinate, and we're going to add B to the y coordinate. And if those numbers are negative, then you're going to add a negative number. You're going to go, left or down, depending on which one you're talking about. So ultimately, the coordinate x, y would go to whatever x plus a is and y plus b is. All right, so for example, if we had the point -2, 3 right here, and we translate it along this vector 7, 4. So we're going to add 7 to this x coordinate, so -2 plus 7 is going to get us, -2 plus 7 is going to get us to 5. And then if we go from 3 and we're going to go add 4 to that, we're going to end up at 3 plus 4, 7. And so that new point, if this point is our pre-image, our image is going to be the point 5, 7 after we've added that. So we can do that with larger images. So graph each figure and its image along the given vector. We've got triangle EFG at these vertices. So E is at -7, -1. So that would be right down there. F is at -4, -4. So -4, -4. That's where F is going to end up. And then G is at -3, -1. So -3, -1 right there. So that was E, F, and G forming a triangle. All right, so then we're going to make this translation along this vector 2, 5. And so we're going to ultimately take our x coordinates +2 and our y coordinates +5. So you could do it without looking at this at all. You could do it just for like E. If I go -7 +2, I'm going to have -5. And then -1, if I add 5 to that, we're going to end up at 4. So I could plot the point at -5, 4. So -5 and then up 4 would be where that point would end up. I'm going to change this up. And that would be where E prime is after this translation. But what we've done here is we've actually kind of shifted this both to the right 2 and up 5. If we go right 2 and up 5, we'll end up at that point. We could do the same thing for G without doing the algebra. We could go the right 2 and up 5, right 2, up 5, right along there. That'd be where G prime would be. And we could have seen that algebraically how we got to that point. I guess I did maybe these out of order. -3 plus 2 would put us at -1. And then -1 plus 5 would put us at +4. And you can see that's where I ended up at -1, 4. And then finally, F, we could do the same thing. We're going to add 2 to this -4 and get -2. And then -4 plus 5 puts at 1. So -2, 1 is where we're going to end up at. We also could have counted 2 to the left and 5 up to get to that same point. Do this in green. So that would be F prime. And we get our triangle. And it's basically all been translated up in this direction, right? These points all moved 2 to the right and 5 up. G moved to the right, 5 up, and then F moved to the right and 5 up. And that's how we get to from this triangle down here to that triangle up there. All right, so then this time around in part B, we've got a square with the points J at 3, 4, so 3 up 4, so that is J, put a J next to that. The next point, K, is at 5, 2, so 5, 2. And that's where K is going to start. And then we've got L at 7, 4. So 7 right, 4 up. And that was L. And then M is at 5, 6. So 5 right, 6 up. We'll put us up there. And so we end up with that. It is a square. It kind of looks like a diamond right now, but it is. All those points are equidistant. So then we're going to go with this. We're going to translate along this vector. we're going to add -3 to the x coordinate, add -4 to the y coordinate. So we're going to add -3 to the x and add -4. Or you could just think of it as subtracting 3 and subtracting 4. So, for instance, the point like J, I could go -3x, so 3 left and 4 down, and realize we're going to end up there with J prime. We also could have done it, algebraically thinking about this point. If we subtract 3 from that coordinate, 3 minus 3 is 0. 4 minus 4 is 0. And so we're going to actually be at the origin with our J prime image. So this is our pre-image. All right, then repeat that process for each point, right? Basically, I'll kind of go through these, I guess, more quickly here. K, we're going to go -3, -4, so that'll put us at 2, -2. L, we're going to subtract 3 and end up at 4 minus 4 is 0. And M, -3 puts us at 2, and then 6 minus 4 puts us at 2. And so if I go through each of those points, that I could just kind of plot those points now, and we'll see how that thing has translated down. So 2, -2, 4, 0, and 2, 2. So we can see that this thing has shifted, 3 left and 4 down to get, and to get shifted down there, or translated down there is the proper term. And so that would be M prime, L prime, and K prime. All right. So this one we have an interesting one, another kind of an application of this. In one part of a marching band's performance, a line of trumpet players starts at position 1 over here, and so we got a line of points. That's kind of our image that we're going to be starting with. Start at position 1, marches to position 2, and then to position 3. Each on the graph represents 1 step, so this is them stepping. Apparently we got the 50-yard line, 40, 30, and I don't know if this is realistic at all, but each unit is as a full step. So yeah, 2.5 yard steps, I guess. That seems kind of big, I guess. I'm not sure. Anyways, we'll go with it. So describe the translation of the trumpet line from position 1 to position 2 in function notation and in words. And so in function notation, what we're going to do is we're going to show it. We're going to actually use like the coordinates. So we're going to take x, y, and see what happened to x and y. What are the operations that had happened to each of those? Well, the y coordinate didn't change at all. So that part's kind of easy. We just can go with y is what it was before. But x, we can see here. So like this here, we would like this point here is a pretty nice one at that intersection here. If we go with this adjoint, that's 8. I guess that's the units we're using. I guess we're ignoring the 50, 40 down here. So we're going 8, and then it's down to 0, down to -4. So we went from 8 to -4, which means we went 12 units that way. If we do the difference between those. And so it was ultimately the x minus 12 units. And that should be true of all these. If you figure out what those points are, like this one was up here at 12 right there, and it went to 0. This one's up here at 14, went to 2 in the x direction. The y direction stayed the exact same. And so that's what it would be in function notation. And then if we wanted to write it out in words, what they're doing is they are going to take move left. They're going to move, each person's going to move left, and I guess what these were, we're just going to position 2. We're going to move left 12 steps. And that's if we're going with, if we're going with this as actually being 8, if that's the way that they're labeling that for these steps, we're moving left 12 units. It's every line represents 2 units, the way that they've labeled this. So if you thought that was like 6, that it is 6 lines, but the way they've labeled this is 2 units per every line. So maybe that makes more sense that this is 8 steps as you go 10 yards. Maybe, band folks, you can tell me if that's more reasonable. All right, so that's what we have got there. Then they want us to describe the translation of the trumpet line from position 1 all the way to position 3 using a translation vector. So what we've done here is we're going to do the vector of kind of both moves all together. So we moved here and down. So x, we've moved -12, and then we want to figure out how far down we've moved from this point up, or backward if we're facing this way. Yeah, we're facing the audience up here. So we could pick any of these points here. Looks like we start up at, so if that's 4, this is 6. So we went from 6 down to, how far was that? So that was 5, 4, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I counted that properly. -9. So we could see, I think we were up at +6, and this must have been -2, -3, because that would have been -4. So we went from up 6 to there. And we could look at another point like this one. We went from 8 up to -1, and so that would be -9. And if we wanted to describe that, so that would be our translation vector. If we wanted to describe that in words, we'd say, yeah, you take your 12 steps left and then your 9 steps back as part of that translation on the field.